Alright, I hope you guys are doing well. Okay, for today what I'm gonna do is I'm gonna come up with a little preview video on the further units that are offered in the University of London program. Okay, so the unit I'll be going over today is actually the elements of econometrics, or for short we call it EOE. Okay, it is a compulsory module for the course Economics and Finance, and those people who are taking economics, you can also choose to take this as one of your further units. Okay, so what I'm going to go through today is basically what are the unit prerequisites for this, what are the myths about this unit, and I'm going to give a short summary of this unit's objectives. I'm going to give you a short syllabus breakdown. I'm also going to show you what are the recommended textbooks that I've been using and the learning materials that are really useful, and also, most importantly, how to study for this unit. Alright, so let's go through the first thing first. The first thing would be the unit prerequisites. Okay, so what do you need to actually be eligible to take EOE? Okay, you're gonna need Introduction to Economics for sure, so you gotta pass that, and you need either Mathematics 1 or 2. Okay, it's either Mathematics 1 or 2, so if you don't have Maths 2, you can still take this unit. Alright, Stats 1 or Stats 2, same thing. You don't need to have Stats 2, you just need to have Stats 1. Okay, so here are some common myths about the unit. Okay, and really I've thought about it, and it just happens to be a bunch of bullshit. So here are the myths about EOE, right? Now the first thing is that it is a must to take Stats 2. Okay, not really. People say this not because they think that it is a prerequisite, but they think that with Stats 2 knowledge, okay, you're gonna be able to pass EOE, right? That's nonsense. Okay, personally, I took EOE without Stats 2 and without Stats 1, and the reason why I didn't take Stats 1 is because I've been exempted from it. And some people say that you need a strong background in statistics if you want to pass or do well in this subject. Right? It's not true. Okay, I was exempted from Stats 1 because I was from a polytechnic, and they used to teach statistics back in poly, but it was just those basic statistics. The only shit that I can remember from poly back then was what was mode, mean, and medium. Okay, so I went into EOE without any stats background whatsoever, and I can guarantee you that you do not need any statistical background, okay, to do well in this module. Okay, now the third myth about this is that people think that you're going to be well versed with econs concept. Well, that's not true. Okay, you just need to have a little bit of the basics, that's all. Okay, they don't really test you on economic concepts, so you don't have to worry. Now the most important myth that we gotta clear is that people think that EOE is tough. It is, as for every unit, as for every subject, as for every other discipline, if you don't study, obviously it's going to be tough. So I can tell you that if you just stick to your own study routine, if you just be consistent, it's not going to be tough. Alright, you don't have to worry about it. Okay, so alright, so now that we're done with the myths, okay, let's start with a little bit of unit summary. Okay, so I'm going to give you a little summary about what econometrics is about. Okay, so I hope you can remember that back in your first year when you're studying Introduction to Economics, you learned about the consumption function, right? Keynes' consumption function in macroeconomics. So you got consumption equals to C naught, okay, which we like to call autonomous consumption. Okay, plus C1 multiplied by YD. So YD over here is your disposable income, and C1, all of us know that this is your marginal propensity to consume. Okay, so now the objective of learning econometrics is to be able to estimate this figure and this figure. Okay, you might think it's easy, but it's actually not, because the type of data that we collect is going to affect what kind of estimators we get. Okay, so basically when we find out something, when we manage to estimate C1, basically we call it an estimator. Okay, so we denote the estimator using this thing called caps, or we can use any other notations for it. Okay, so basically what we want to find out here is that with with a unit change in your disposable income, okay, maybe if I'm $1 richer, how much is it going to increase my consumption level? So that's all I want to know. Okay, so that is basically what my MPC is telling me, right? My marginal propensity to consume. And C0, as we all know, is autonomous consumption. So basically it means how much consumption do we have, okay, if we've got no income at all. Okay, so that is the idea behind econometrics. It is gathering data from a sample, okay, from a population, which is like a sample, okay, and then you're gonna plot it out. Okay, so maybe let's say I go up to you and say, hey dude, I'm looking for somebody who earns maybe $300 a month. So do you earn $300 a month? Oh, you do. Okay, great. Okay, so I just want to ask you, how much money do you spend in a month on consumption? Okay, so you're gonna tell me a certain figure. Okay, so basically on the y-axis here, I'm gonna have C, which is consumption here. So this is what we call the dependent variable, and this is what we call the explanatory variable. Okay, so this is my explanatory variable, my disposable income. So I'm gonna ask you, do you earn $300? You say yeah. Alright, so $300 is here, and you tell me that your consumption is at this level. I say okay, fine. Okay, and then I'm gonna ask somebody that earns maybe $1,000 a month. Say, hey dude, how much do you earn a month? Okay, you earn $1,000, right? Okay, yeah, perfectly the guy I'm looking for. So how much do you spend in a month? Okay, so he says that he spends maybe this much level. So I keep getting information like that. Okay, and basically I'm gonna have a lot of data right here. Okay, and econometrics, okay, which is basically about regression. You just basically draw a line straight through, and what you have over here is your linear regression. Okay, showing the relationship between consumption and this thing called disposable income. So this thing called this C0 over here, which we like to know as autonomous consumption, is basically the amount of consumption that we have if we don't earn anything. So it's right here because this is 0, right? And the slope of this line is going to be your MPC. Okay, so you might think, oh, econometrics doesn't seem that bad. Okay, well, it is not that bad. Okay, the thing is that the type of data we have has got certain properties in it, you know. So these properties are the ones that actually make our life pretty difficult. So as you can see, this line is obviously C equals to C0 plus C1 multiplied by YD. Okay, but if you realize all this data over here, they deviate away from your regression line, right? There's a distance in between there. So these are what we call errors. Okay, it's called errors, and that's why in econometrics, the thing that really differentiates econometrics and basic maths is that there is something called an error term. So this error term is the one that starts to complicate things both mathematically and statistically. Okay, so this is a rough summary of what econometrics is about. Okay, it is about finding estimators that are unbiased and consistent and efficient. Alright, let me write that down for you in another color. Unbiased, alright, consistent and efficient. Okay, so what unbiased means is that if, let's say, I were to take an average, okay, what we like to call expected value. I think some of you might know. If you take the expected value of this estimator, do I get the true value of it? Okay, now all this is shown mathematically. Okay, basically there is a technique. There is a specific technique on how we're going to estimate C1. Okay, we call it the least square procedure or ordinary least squares. Okay, and if certain assumptions, which I will go through with you later, are satisfied, we will get these three conditions. Okay, so basically we are looking for estimators that are unbiased, consistent and efficient, and in EUE what you're supposed to do is to learn how to get these three conditions. That's all. Alright, so unbiased basically means that on average do they tend to be will they turn out to be the real value? Consistency means that if I'm going to increase the amount of sample size, okay, maybe, you know, it's really impossible to have everybody, to survey everybody in the population, to ask them about their consumption and income. And I don't think everybody is comfortable with me asking them how much they earn and how much they consume. So the theory behind this is that if we were to increase the sample size to infinity, will we still get back the original value of the estimator? Now, like I say again, okay, these are all going to be proved using algebra, not maths. Okay, and efficiency is basically variance. Does it have the lowest variance? Does this estimator have the lowest variance? Okay, variance is an important thing because we do not want the value of it to be jumping here and there. We want it to always stick within a certain region. Okay, alright, so now that was a summary. I'm not going to go through the syllabus chapter by chapter. I'm not going to go through everything in one video, obviously. Okay, I'm just going to tell you what we are going to do, you are going to do, okay, during class. Alright, so now the first thing that you guys are going to be learning, I mean, if you are in the same institution as I am, okay, this is basically what's going to happen first. Okay, now the first 3 to 4 weeks, okay, you're going to start with the review of stats basics. So you're going to learn things like your t-test, your f-test, alright, you got your chi-square test, okay, and you gotta learn how to construct confidence intervals, okay, blah blah blah. Okay, now all these things are basically to test whether your estimator is significant or not. Basically what it means to be significant is this: if it's insignificant, that means disposable income has got no relationship with consumption at all. Okay, that's all. That's if it's insignificant. If it is significant, that means there is some effect. So you'll be learning how to use this test, okay, to determine whether it is significant or insignificant. Okay, so there will be some basic review on how to do hypothesis testing, etc. Okay, so you learn things about expected value as well. Expected value and all the other things about unbiasedness, consistency and efficiency. Okay, and you'll also be learning this thing called the maximum likelihood estimation, the basic part of it, because you're going to be using it later on in the chapter. Okay, so that's the review of stats. Okay, now for the next chapter, the next part you're going to go into is simple regression analysis, right? Simple regression. So basically in simple regression, okay, there's only going to be one explanatory variable. So let's take y for example. So y is your dependent variable, and you want to find out how does y behave with respect to certain variables. So let's say we have got beta naught. Now beta naught is a parameter. What it means that it is not a variable. It is basically, if let's say my explanatory variable is x, so beta naught, okay, is the value of y when x is 0. That's all. It's like an intercept, vertical intercept, alright? And x is the explanatory variable, and beta 1 over here is the marginal effect of x on y. So that means if x increases by 1 unit, y will increase by beta 1 amount. Okay, and don't forget your error term here. We already gone through what the error term is. Okay, I don't want to talk so much about the error term, but because I want to keep you in suspense, you're gonna love it. The error term is like what we talked about. Okay, every time you estimate something, you're never gonna be accurate. There's always gonna be some error. So that is the error. That is basically what this little mu thing here is for. Okay, now there are certain assumptions that you will need to know. Okay, these are the most important things. Alright, they are called the GM assumptions. Okay, basically it stands for Gus Markov. Alright, I've got no idea who this guy is, but basically that's his name. Okay, this guy happened to be just, I don't know, he came up with a few assumptions, and the problem is that for simple regression, all these assumptions are satisfied. Okay, the next few chapters are the ones that are gonna worry you, because that is when all these GM assumptions break down. So the whole study on EOE is basically teaching you how to tackle with regression if the Gus Markov assumptions break down. Okay, so that's about it. Okay, moving on, next chapter what we have is we have got multiple regression. Alright, so we've got multiple regression there. And what we mean by multiple regression is that now there's going to be more than one explanatory variable. Okay, there's going to be x1, there's going to be x2, there might be x3, blah 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 blah. Okay, maybe there might be, I don't know, we'll just call it bk and xk because k may be a really huge number, okay, plus u. So basically now there are more than one variables that's affecting y. Okay, like maybe inflation is caused by more than just your price expectation and your wages and your markup and whatever. So using multiple regression is really useful for more realistic models. The GM assumptions still stay there, okay, and then we go on to the next chapter of transformation of variables. Now the thing about this is that look, everything here is linear. So if you have to estimate something like, maybe do you remember Cobb-Douglas utility function or production function? So utility equals to x to the power of a times y to the power of b, and now you realize you gotta estimate a and b. You can't just ask for people, their x and y's and just draw a simple regression line through that. You can't, because this is non-linear. Okay, or maybe you would have like a production function, which is also Cobb-Douglas style, and you've got capital to the power of a, label to the power of b. So what you want to do is you actually want to ln these two things together so that you can actually get this. Yeah, so when you do this kind of transformation, there are also implications, but trust me, these implications are really not that bad. It's just a little something extra. Okay, alright, the next thing you're gonna do is dummy variables. Okay, so that's dummy variables. So dummy variables are pretty interesting, they're pretty fun. They are basically like all these explanatory variables that take the values of 0 and 1. So the purpose of it is to account for more I don't know, qualitative variables. Right? For example, if you're gonna talk about consumption, right? So we know that consumption is C0 plus C1 YD, and we also maybe wanna have a C2D. So what is a D? D is basically a dummy variable. So if let's say D takes a value of 1 if you are male and takes a value of 0 if you are female. So what we do is we run the regression, we get the data, okay, and if you realize that this dude is a guy, obviously the dude is a guy, if this person is a guy, okay, then this is going to be equals to 1, so it makes your vertical intercept different. It makes your vertical intercept C0 plus C2 instead. So because this is a 1 over here, if it's a 0, then it remains as C0. So basically that's dummy variables. Okay. It's one of the more fun topics. Alright, moving on, we have heteroscedasticity. Alright, the next thing is gonna be heteroscedasticity. Okay, this basically occurs when your the variance of your error, okay, the error like what we just talked about here, this error here, okay, is not constant. Okay, you're gonna be learning more of this. Basically, it's just how to deal with the Gas-Markov assumption, failing that the error terms has to have constant variance. Okay, so that's heteroscedasticity, and then the next one they're going to is stochastic regressors, okay, and measurement errors. Okay, sounds pretty intimidating, but it's not. Okay, do you remember me just now saying that I want to go to a guy and I ask him, hey, are you earning $300 a month? Hey, are you earning $1,000 a month? The reason for doing this is because I specifically want to find somebody that's $300 a month, somebody that's $1,000 a month. That makes this non-random. Non-random basically means that I decide what value this is going to be. Okay, if it's random, basically I just get like a random making machine, random number generator and find out a value for it. But no, I want to be specific. I want to find out if this is $300, what is this going to be? If I want to find a male, what is this going to be? So that's what it means by non-random. Non-random, okay, is also known as non-stochastic. Alright, so obviously when it says that the regressors are stochastic, so it means that it is random. Okay, there are many reasons why the explanatory variables might be random or stochastic for that reason. Okay, but basically what you're supposed to do now is how are you gonna tackle the regression if let's say you are facing stochastic regressors or you got errors in measurements. Okay, so errors in measurements might be like, hey dude, are you earning $300 a month? And you go like, no, I'm earning maybe 500. So you're lying, right? I mean, I don't know whether they're lying, so I gotta account for the lie. So that's what we call measurement error. Okay, and moving on, we've got simultaneous equations. So maybe like a demand and supply function. Okay, plus something else. I'm just throwing out random things here. Okay, plus an error term. And then there's a price. Okay, we call it B1, Q plus maybe B2, X plus whatever. Okay, so in simultaneous equations, you need to learn how to estimate A1 and B1. Okay, so that's simultaneous equations. Alright, so then we go on to binary choice. Okay, chill. I think you might be worried that that's a lot, but no, it's not. Okay, we're almost at the end now. Okay, binary choice. So basically now the issue is that this can only take the value of 0 or 1. Okay, because we want to find out between 0 and 1. Between 0 and 1. Okay, y can only take the value between 0 and 1, and the reason why we want to do this is maybe because we want to find what is the probability of something. Maybe y is the probability of getting married. Okay, so if y is 1, the person is married. If y is 0, the person is not married. Okay, so we are finding out, we're going to use explanatory variables to find out what is the probability of the person being something or being something that's not. Okay, so that's it. And now we move on to the last chapter. Okay, the last chapter is on time series. Alright, time series. Okay, so now time series. It is basically a different type of data set. Whatever that we've been talking about just now was all cross-sectional data. So basically cross-sectional data is I go to you, okay, I want some information from you, then I go to another person, I get the same kind of information from him, I go to somebody else, and then I got a sample. Time series is basically I go to you, I ask you what's your income, okay, what's your expenditure this month, and I say alright, I'll come back to you in a month later. Next month I come back to you and I ask you, so dude, what's your income right now? So what's your consumption right now? So basically I keep following up with you and I have a time series on your information. So that is what we mean by time series. And to be honest with you, time series is the more challenging topic in econometrics. Okay, but you shouldn't, if you are going to take econometrics, take time series very seriously, because for all the past year papers, for the past 4 years, they have been testing time series like a lot. Really is a lot. Okay, so do take note of time series. Okay, I'm not going to talk much about time series, okay, but it is a long chapter, and if you can master time series, you're gonna master everything else. Okay, so that was a summary breakdown. I hope that wasn't too long. It's already 23 minutes into the video, 23 minutes plus. Okay, now what I'm supposed to go through with you is I'm going to recommend you the textbooks and the learning materials. Alright, now the textbook, the recommended textbook by the subject guide is called Introduction to Econometrics by Christopher Dougherty. Alright, so this is the textbook. It is the 3rd edition. I ordered this online. Okay, and that's the author's name. Alright, and really this helped me a lot, you know. Apparently, because this is a second-hand book, there was some Chinese guy that was using this book, and I can't read this shit, but no, it doesn't matter. So, yeah, this is the syllabus textbook. This is recommended by him. So he sets all his tests, you know, all his papers using this stuff. Okay, and yeah, this is the book. Okay, Introduction to Econometrics. If you need the IBSN number, The IBSN number is over here, but they have a fourth version. They have a fourth edition now actually. So maybe you might want to get the fourth edition, but this works totally fine. Okay, so this is the textbook. Alright, now there's something I want to recommend to you. This is not recommended by the subject guide, but I use this and it saved my ass. Okay, it really helped me a lot, and I gotta owe everything to this book. Alright, this is the book I'm talking about. Okay, it's called Introductory Econometrics, a Modern Approach, by a guy called Wodrich. Okay, it's got really a lot of information inside here. This is it an edition, or apparently it's just called the International Student Edition. Alright, so I borrowed this from school. Just let me check whether there's an IBSN number or not for you. Okay, doesn't look like it. Oh, there it is. Okay, so these are the numbers over here that you want to take note of. Can you see it? Okay, yeah, these are the numbers. Alright, so pause the video if you want to get the numbers of it. So this book is really good. Read everything on it except panel data. Okay, I say again, read everything on it except panel data. Understand the book fully, you're gonna get an A for this unit. Alright? Okay, so those are the recommended textbooks, and there's something else I want to show you guys. There's this website that is amazing. Alright, this is done by that Christopher Dougherty guy, the guy that wrote the first textbook. Okay, and this is the website. Alright, check it out. He's got like tutorial videos on this, okay, and he's got tutorial videos for most of the topics. Okay, there's like revision video, okay, and this review chapter is amazing. Okay, it really teaches everything about the basics of statistics. So yeah, there's exercises too. Okay, so I really recommend that you go to this website, and the website address is this. I hope you can see it. Just let me focus this for you. Alright, so this is the website. Feel free to pause now if you want to. Alright, okay, so now I'm going to bring you back to my desk over here, and I'm going to go through with you how to study for this subject. Okay, now, just personally, let me tell you my personal strategy of how I did this. Okay, I ordered the textbook online, the blue one, alright, the one called the Dougherty one, the Introduction to Econometrics. So what I did was, when it arrived, I started reading it, and now the thing is that, okay, I started studying for this subject about 4 to 5 months before school started. Okay, what I did was I was kind of, okay, you may call it desperate, okay, but immediately after my exams last year, okay, for my first paper, the next day I drove down to school and I started borrowing stuff for the second year, and I studied for my second year modules immediately after my exam started. And it wasn't stressful because I just read for leisure, you know. Trust me, I didn't understand shit. Okay, I couldn't understand shit because it was confusing to me. I had no statistics background, you guys know that. Okay, and it was really tough for me because I really had no background, but I just read it for fun, you know. I just read it for leisure, and when school started, everything was so easy. You know, everything was so easy because, you know, I kind of had an idea what was going on already. Okay, so that was my strategy, and what I did was to do all the past year papers. Okay, do all the past year papers. You know, they give you 3 years worth. They got examiner's report in it. Okay, so take it seriously. Study do the questions first. You know, crack your head over it. You know, be stressed over it. You know, pull some hair over the questions. Realize that you won't be able to do it, and then look at the examiner's report for the answers and be enlightened from that. Most of the time, he's going to refer you to the textbook. So that's why it's really, really very important for you to have the textbook. Okay, anyway, my lecturer was great. Okay, I mean, I'm in Singapore and I'm studying at the Singapore Institute of Management, and there's this guy called Dr. Radha. He is great. Okay, this is another Indian guy. You know, he might speak a little bit fast sometimes, but you know what's the great thing about him is that he's always willing to help. So if you know your stuff and you know what you do not know, you just go ahead and ask him and he'll help you for sure. Okay, so just like every other subject, if you're gonna work hard, you know, it's gonna be fine. Okay, you don't need to be a smart ass to be good at this. You know, you just really need to be consistent. And the reason why this subject is easy as compared to things like macroeconomics is that because macroeconomics, you know, you can answer it in many different ways. As for EOE, there's only one standard way, you know, because it is scientific, it is stats, you know, it's maths. So the answer is just like that, you know. You don't have to beat around the bush. So yeah, that's my review for econometrics. I hope you found this video useful. I'll be doing videos for managerial econs and macroecons too. Okay, so thank you so much for your time, and I hope you guys enjoyed your holidays, and yeah, have a good one, man.